Yeah.
There we go. Okay. I'm Chris Gregson. I'm with Ares Research, which is me and a guy. So, but we like playing with networking stuff, not just like your links and stuff. We just go out and find strange stuff and just start researching it. This project started long ago, about 5 years ago when I was at work. Some guy brought in a MacBook and he's like, oh, no one can hack me and all this type of stuff. And of course, I just started sniffing the network and we're on a switch network, so I shouldn't see much. But I started seeing these UDP traffic broadcasts going out. And of course, UDP going out of a firewall means UDP can go into a firewall. So I now have an entryway. But I wanted to study more about this set of protocols, which grew into this whole big project. Anyhow, local link networking. Basically, everything before a router. It's like you get 3 boxes together, that's your local link. Billions of names. You name a vendor, they have a new name for it. Well, like maybe in the 80s, but anyhow, they had a name for it. So this stuff's already pretty much familiar. LAN protocols. Once again, 80s technology. You had a whole suite of stuff that, before TCP/IP was around, before you may have had a shell account, but when you had a local network, no router, no DSL, whatnot, you were playing with these protocols. NetBUI, all this stuff. IPX, SPX, great one for games. You want to play quick. You don't have to set up anything. You just put the 2 boxes on and go. No TCP, none of that neat stuff. That's why local networking was awesome. This is what got me into networking. Anyhow, TCP came around and said, we don't care about the local network. You want to reach the internet. And so now when you want to play quick, okay, who's setting up the server, what port is it on, what IP address, oh, something's not working, blah, blah, blah. Half hour later, you have a LAN party. However, protocols are roughly coming into mainstream now that are bringing back the local link networking stuff onto TCP/IP. You have everyone's favorite universal plug and play. Became very popular in the 2000s with vulnerabilities. And that's more of the higher end stuff. I'll get into that in a sec. You have Zeroconf, which is being heavily pushed by Apple. Actually, Zeroconf is what made me a Mac user because their networking is just awesome. Anyhow, SLP smells like Novell. Pretty much, this is actually the initial protocol that I started studying. The guy started sending out SLP packets. This is kind of a hybrid one. You still need you sort of need a centralized box that pretty much stores all the information and is like a proxy, like directory. But you don't fully need it. It's kind of a funny protocol. SLP is dying out of phase. Everyone's jumping over to Zeroconf or universal plug and play. But anyhow, why do we want this? Because when we're at home, we just want things to work. We want games to run. You bring a friend over, you just want to play the game. You don't want to deal with all that stuff. Because really, you set up your network, you set up once, you don't have to deal with it. When you set up a game, you're only going to be playing the game for maybe a couple hours. How much time do you want to spend into configuring your network to play a game for a couple hours, then destroy it? And so that's why we're dealing with ad hoc networks. Basically, right now, 3 people in this room can jump on a wireless network, not have to set up anything. They don't even have to know each other's name. They just know like Bob, George, and Jim Bob. And they can start playing quick right here instead of listening to me. That's the beautiful thing about LAN protocols. You see here, the 2 major competitors are pretty much angling at different directions. Universal plug and play, heavy on links as firewalls and whatnot. You can totally mess over firewall rules using universal plug and play. Whereas Apple's pushing, for some reason, heavily about printers. Finding a printer. Not like they move around that much, but they do. You can find it very quickly. I don't know what their whole thing with printers is, but anyhow.
Those Apple printers.
Right, and so here's the protocol. Can you hear me?
Yeah.
Okay. You got TCP, for nice stasis on the left, and then you have basically the broad how local link networking works. You don't care about the physical stuff. If you can get the wires to connect or wireless to connect, you can set up local link networking. And then you have the 3 major suites of how they're implementing it. Zeroconf is starting at the bottom up, Whereas Universal Plug and Play borrows some stuff from Zeroconf, but mainly goes for the application stuff. Mainly to get all the various vendors to agree on 1,000 different standards, rather than not agreeing on 3 million standards. I don't know. And then you have SOP, which kind of does that, and it pretty much just deals with what services are out here, who's got what, and all that type of stuff. Like I said, it's pretty much being phased into Zeroconf and Universal Plug and Play. The main thing is, I wish I did a little thing on there. I'll figure that next talk. But anyhow, basically, cause no harm. If you have a enterprise system, whatnot, you don't want 3 guys playing Quake to mess everything up for you. And so, therefore, local link networking has to play nice with any established network well, it doesn't have to, but it would be nice if it would just play nice with everything else, so you don't mess up your wife's printer while you're playing Quake, whatever. And so, also, each layer is pretty much a la carte. If you only want one piece, you don't have to have the rest. That's the beautiful thing about this. Addressing layer. Most people consider automatic private IP address as DHCP failed. That's kind of true, kind of not. Because of the previous slide of making sure you work nicely with everybody, you want to make sure that if DHCP is on the network, you allow it to configure IP. If DHCP is not on the network, then hey, let's find an IP address. Everyone else looks at it as DHCP messed up, and now we have this backup address. No, this is actually a really neat setup. You have a whole, I forgot, I think it's a whole class B, and it'll pick a random IP address, do an ARP query of it, see if it's free, and then take it. And then, all your other buddies do the same thing. And so your IP addresses are done. You don't need DHCP. You don't need to configure anything. It's just IP addresses work. Here's what I just said. Anyhow, the naming layer. If I don't know my IP address, I'm not going to tell Bob what my IP address, and then he won't know what IP address to put in. So therefore, we need something I do know. I'm Bob. I have Bob's computer. That's the name of my computer because I'm creative. Anyhow, so with Bonjour or whatever they want to call it this week, it's MDNS, but Apple calls it Bonjour. They used to call it Rendezvous, or maybe they do call it Rendezvous. Anyhow, they have a fight between names. So there's like 3 or 4 names for the same thing, which is MDNS. Just think of it as that. Macintoshes use the .home TLDs, whereas vendor-neutral stuff like Linux will use .local. So my box is now Bob's computer.local. So that way I can tell George over there, hey, connect to Bob's computer.local. And his computer will automatically know how. And why? Because of magic. Multicast DNS. Basically, it's just like your normal DNS. Uses UDP packets. However, it goes across a multicast address, which means it's hitting everybody that's listening to it. And it's hitting on port 5353. Therefore, every computer that's using this is a DNS server and a DNS client. He wants to find out who Bob's computer is. He doesn't know what my IP address is, so he can't ask me to resolve it for him. He asks the multicast address, which is now popping to everyone. And the first person who knows what Bob's computer IP address is will respond saying, hey, it's this IP address. It's beautiful. It's like, you don't have to, it's blindly sending out a prayer and wow, people actually answer. So that's why it's magic. It's really, this is a really amazing system. It is susceptible to a lot of problems because he can say Bob's computer is whatever. He can say Bob's computer is whatever. This is just to get things to work. Security is a whole other issue. I imagine in 5 years when there's a bunch of things on bug track, some guy will come up with, hey, let's use crypto, but oh well. Each node will attempt to resolve its own name. Basically, if I want to know what Bob's computer is, I'll try to see if it's taken. If it's resolved, it's taken, not mine, no big deal. I'll pick a new name. If it isn't there, then I'm Bob's computer. And then, of course, every single DNS request I see and answer, I'll cache, mainly for two things: either to save bandwidth, or let's say I reboot my computer. Now who's answering for Bob's computer anymore? No one. Well, he's got it cached already, and so he'll send it out. So that's the nice thing about this. The discovery layer. I want to play Quick. What's the Quick port on? Who knows? It could be
666.
there we go, 666, or he's being security-wise, 667, whatever. Anyhow, I don't know the port number. I can't tell him the port number. How does he find the port number? Easy. We make a DNS request. Multicast DNS request where we're saying, hey, we want something that ends with a TCP, and it's this protocol, the Quick protocol. And turns it out, one guy says, hey, I know a Quick server protocol that's a TCP, or probably UDP for Quick, but anyhow, here's the port number. And voila, we're now using DNS, in this case, multicast DNS, to do service discovery, ports, and stuff like that.
So what happens if the security conscious guy uses 667 and he goes, hey, I know what that is, it's 667, and you got somebody over here who says, yeah, I know what that is too, it's 666. How do they all agree they're going to come on what port?
Well, Quake would first do a search for who's got the Quake protocol. And he'll see that you have it on your box at 667. He'll see that he has it on his box at 666. If he's lying, that's another story. In this saying, no one lies. That's just that you have to accept that. But I'll get a list of people saying, there's this server with this port, this server with this port, and it's all nice and handy. This is really great for web stuff. You have 5 web servers. Your Safari and a couple other add-ons will automatically show you what web servers are on your network, what ports are at, all that neat stuff. This is the whole purpose of Zeroconf. All that other stuff was just to get it so that you can look around and find out what services you have. And so Zeroconf pushes this heavily. Microsoft kind of does something with it, but kind of lets it go because they went big on universal plug and play. This is what I was talking about, the web server stuff. This is not exactly what I just talked about. This is actually something even better. I set up a Maryland 2600. We're a couple states north, but anyhow, I set up a centralized DNS server that Bonjour can actually talk to and do the same thing that it does on multicast. However, on the server I have basically plugged in a bunch of bookmarks. And it will tell Bonjour that, hey, there's all these servers at these locations with these paths and all that. And so we're having an Internet Explorer with a Bonjour add-on. And it'll go out, it'll find out, like for instance, Danielle Gregson, my wife, she's at the house. Yeah, that's her computer. It detected her on the local network. Then it went out to my central server and found, hey, there's all these, MD2600 mailing lists. And so, it's a nice way of sharing bookmarks without doing it. Nice application of this. You take your computer to Jim Bob's Crab Shack. He's got Wi-Fi. He wants to tell everyone, hey, here's the menu on Wi-Fi. You don't have to know what webpage to go to. You just open up this and like, hey, Joe's Crab Shack Wi-Fi, or menu, click it, or whatever. You can push out, you can basically announce bookmarks without forcing people to go to things, or basically giving them the option, and it's just neat. This is Microsoft's. Microsoft tried to do the simple service discovery protocol, which deals with XML and SOAP and all that stuff. Don't mess with it, unless you want to break something, and that's a great thing. And even Microsoft, they sort of have tried it, and then they kind of stopped. And even their developers said, yeah, we like Zeroconf better. SLP, it's one of the few RFCs related to this right now. However, it's pretty much phased out. SLP was set up by Apple, Sun, and Novell, which amazingly either has done local networking or is doing local networking. But these things are less popular, like I said. Application layer. this is Microsoft's, cake. Universal plug and play. Basically, we're saying if you have a firewall, agree to this firewall rule set or protocol that we'll shake hands on. If you don't, well, try to make something up. Vendors seem to like it. I don't know why, but they do, and they're going nuts over it. So you will have to deal with this, and you'll probably be putting this on top of Zeroconf. Yeah. Implementations, universal plug and play on every single Microsoft thing. You already have it, or unless you don't use Microsoft, of course. Bonjour is the Apple implementation. Avahi is the Linux version of all this. Nice thing is that Apple's Bonjour is open source. The code's out there. You can play with it, you can rewrap it, all that neat stuff. And of course, the Linux version, same thing. So this is actually helping out with development of new protocols and new tools to play with this. Apple also has a Java SDK, so you can quickly make an application that chats over this without knowing IP addresses or ports. Security concerns. If you're dealing with security, don't deal with this at all. Denial of service. Hey, Joe's IP address is there now. Everyone believes you. Spoofing. Oh, that's kind of the same thing. Just instead of saying it's nowhere, it's me. Man-in-the-middle attacks. Yeah, I'm the web server you want to talk to. Give me your eBay. And then here's the few RCs, which mainly RC 2608 goes to SLP. The other one goes to automatic private IP address assignment, and then various links. So someone will be distributing this, so you can actually click on them. Any questions?
I heard the Google Talk version of the main inventor of the Bonjour protocol, and he was talking about his goal really was to turn the Ethernet cable into what USB kind of became as, you can plug just a crossover cable between your computer and just about anything, or plug it through a switch, and you have almost the same kind of experience as just plugging something into a USB port. Do you think that that's the primary strength and use of that technology, or do you think it's more in other areas?
Sort of. Basically, you still need something that understands how to talk to Ethernet and IP layer. But pretty much, Cheshire, the guy who deals with all this, he originally was at Red Sun, came over to Apple, made a neat game called Bolo. Ever played it? It's a 10 game. I loved it when I was in high school and whatnot. But anyhow, I'm still studying this guy, so he's an awesome guy. But anyhow, there's this whole idea spun around that time of getting your toaster on the network. Why do we need a toaster on the network? It doesn't matter. We're engineers. We just want a toaster on the network.
Tell when your toast is ready from downstairs.
Of course. And so Sun was going with, we want to put Java on this toaster because it'd be cool. And then, of course, Cheshire's like, well, if I take the toaster and plug it to another wall outlet, what IP address is it now? And so, this is all about home automation, heavily about home automation. But yes, it's pretty much you buy a device from Best Buy, you plug it in, it works. That's what they're all about.
How does this relate to the military requirement for G, that ultimately became G in Java? I mean, does that have anything to do with the universal plug
I don't know.
Okay. I mean, as far as I know, Gene was like a Java spring off that automatically configure a whole set of serial networks or something like that for the military.
What the military starts off with and ends up with is two different things. Like, we have Oracle now. Oracle was, of course, FBI Project Oracle. So, but I don't think the FBI originally saw that. Hey, we're going to have a kick-ass company that features Microsoft.
So, when do you think Bonjour and Universal Plug and Play will be secure?
In 5 years, when something hits bug track and they go, oh my god, and people say, you know, some security, you know, probably Schneider or whatnot, gets paid ridiculous amount of money to say, hey, use crypto.
I mean, there's no encryption.
No, it's
no
like
authentication.
it's like bonjour, you've got a virus.
Yeah.
Pretty much, yeah.
He's very polite about that.
And the problem,
You want to port scan a network, you just say, I want to know all the TCP ports. Here they are. Nice. You know, you don't actually have to probe out anything. You just make one request, and you get every single TCP report. Every single.
Bonjour really operates on the premise that you can't have security on it because it would defeat a lot of the purpose.
Right, it would cut down the usability.
No, not really. You could add
You could do
public
some
keys.
type of
Yeah.
authentication, like all my toasters, or all my refrigerators all have some sort of key in common.
But at that point, you're better off using a DHCP
because the key
server
method
and
is really
running
secure.
the
In general.
discovery portion of
Works great for
anyway.
DHCP,
So
right.
really the bonjour as
Well,
defined as the goal.
DHCP doesn't really change anything with security.
It does because it will need to do with DNS
appetite's here.
in a wide area.
And if you have DHCP and you have internet access, then you could verify that key based on the third party and things like that.
Yes, but once we go to trusted computing, which everybody loves, we don't have to worry about that because BIOS says I'm good. We trust the BIOS. Anything else you guys like to talk? More things like this? I know it's not mainly security related. It's probably security than half of you guys, so.